Okay, can you share my screen? Okay, so last class, just we started what is Kubernetes and so what is the Kubernetes and what are the some of the features of Kubernetes and all just we discuss, right? That one only, right, Karthik?
Yes, sir.
Okay, so Kubernetes. So what is Kubernetes? So most of the people, Kubernetes is an orchestration engine. Docker is a containerization, right? Same way, Kubernetes is an orchestration engine, and this is also open source. This is also open source. Right? No need to pay anything. Almost all DevOps tools is open source only, and so managing containerized applications. If you want to handle container-based applications, and so mostly nowadays we are using Kubernetes and so see container deployment, scaling, descaling. If you want to scale up, we can easily increase. If you want to scale down, we can easily scale down based on your based on your requirement. Based on your based on your requirement. And these are the main features. Automated scheduling. Kubernetes provide advanced scheduling to launch container to on cluster nodes. Now we don't know, right, what is nodes and all, we'll see. And self-healing capabilities. Automatically it will rescheduling, restarting, recreating, everything taken care by Kubernetes. You don't worry. These features is not available in Docker, Docker Swarm, and so right. Here, so whatever we are discussing here, this features is not available, okay, in Docker and Docker Swarm and all. Next, automated rollback. So if you want to Kubernetes support, roll out and roll back for the desired state. Desired state means which state you want. So that and all here it is supporting. And also horizontal pod auto scaling. Horizontal pod auto scaling. Right, AWS, what is auto scaling? What is load balancing? How it will work? Same concept here also. Same concept here also. We'll see. Now, today we are going to see this is very, very important. What is Kubernetes, Kubernetes architecture and what are the main components in Kubernetes? In interview purpose also, 99% of people are asking this question. Can you explain Kubernetes architecture? Or so they are asking like, can you explain what are the main components in Kubernetes? That and all. Okay. See here, Kubernetes implements a cluster computing background. Everything works from the inside Kubernetes cluster only. So here, if you see here, here this is the one is the master, this is the worker node. So one is the master and one is the worker node. It is following master and worker node architecture. Kubernetes following which architecture? Master and worker node architecture. This is the master, this is the main, and these are the worker nodes like a manager and right, employees. Same. See, this cluster is hosted by one node acting as a master. All are same configuration only. Master also same configuration, worker node also same, all are instance only. But see here, only one is acting as master of the cluster, other nodes as others are nodes which is actually containerization. All containers running here only. Okay, so see here, if you manager also employee, you are also employee. But based on experience, right? So one guy acting as a manager, one guy acting as a team lead, remaining all are employees, right? Same format here. So all are instance only, but one instance we are make it as master, remaining all are worker nodes. This is the new terminology. Okay, so this is a Kubernetes master and this is the worker node. This is the Kubernetes master. This is the worker node. Worker node 1, worker node 2. Like this, we can create based on the requirement. We can create a multiple worker nodes, whatever you want. Okay, so see here, one is acting as master and remaining all are worker nodes. Okay, so now see here, these are the user interface. This is the kubectl. These are the command. Right. So Docker, if you want to Docker client, Docker daemon, right. If you send any request, if you send any request, the request to go to whom? Docker client to Docker daemon, right? Same way, if you go here, so here also we are having this is the Kubernetes master. And so here we can configure multiple worker nodes. How many you need? So those many worker nodes you can, but all are same configuration, same setup only. All are in same configuration, and this is the master. This is the master, and these are the worker nodes. Remaining story same only. All are same only. One is master, and but all are instance only same. So if we see here, this is the master. This is the master, and these are the worker node 1. This is the new terminology, or worker node 1 or node 1. We are calling worker, we are calling, so this is the worker node. This is the node 1, and this is the worker node 2. This is the worker node 2, and this is the worker node 3. So like this, we can configure so many worker nodes. So this is, but if you come to here, I am the end user. End user means, so that is, I am the end user. End user means if you send any request, so you can send request two ways. We can send request two ways. One is GUI. What is this? One is GUI, graphical user interface. This is the UI, user interface. And second one is kubectl. Second one is kubectl. This is the GUI. This is the kubectl. Two ways we can send a request kubectl. This is the CLI. This is the CLI. This is the GUI. This is the CLI. Command line interface. What is this? CLI means command line interface. This is the GUI, graphical user interface. Okay. So we can send a request two ways. We can send request two ways. Whether we can send request GUI way or whether we can send request CUI. Whatever you want, right? Same way. This is the, if we send any request, the request go to here. But here there is main, these are the four components. So these are the main four components. So these are the main components. One is API server. One is API. API, API server, and ETCD, and control scheduler, and controller. These are the main four components. So these are the, if you come to master, if you come to master, so these are the four components. So these are the four components. API server, ETCD, scheduler, controller. Same story here. So see here API server, scheduler, controller, and ETCD. And if you come to worker node, so we are calling worker node or node, both are same. Sometimes I am calling node, sometimes I am calling worker node, but both are same only. Don't confuse here. And if you go to here, so here mostly we can see these are the main components. Kubelet, kube proxy, Docker, parts. What are the main components here? So these are the main components. So these are the main components. Now if you go to here, wait, it's taken out. Okay. Now if you go to here, here mostly these are the main components. Okay. One is parts, next Docker, next kubelet, and kube proxy. Kube proxy. So these are the main components. So these are the main components. Same way, these all components available in every worker node. So if you go to here also same, and if you go to here also same. All are same only. Don't confuse here. Everywhere same only. All are same only. Now clear, Karthik? So these are the worker node. This is the one, two, three, like this we can configure. But this is the master. Master, like it is acting as the like manager. It is controlling every worker node. It is controlling every worker node. So any doubt, Karthik, here?
No doubts, sir. Clear.
Okay. Now, if you go to here, we'll see one by one. What is so? See, now simply I will give overview. If you send any request, for example, I am the user or you are the user. Karthik sent one query. Karthik executed one command, the Kubernetes command. So whether it is GUI mode or whether it is CLI mode, anywhere. Suppose you send one request, you executed one query, one command. So that first request go to API server. API server it is act like front desk. If you go any office, there is a front desk, right? What is the use of front desk? So they will help. They will help us, right? Whom do you want to contact? Where do you want to go? Which purpose you came here? Huh? That and all that information they are giving, right? Same way. This is like we are sending GUI or CLI. If you send any request, the first request go to API server. API server receives your request, and so this information and all it is stored into the etcd. This is like so database. It is here. It is stored into the key and value format. Key and value format. And with the help of scheduler, schedule this task to particular worker node, and controller can handle all this information parts and all. So this is the simple way. Now if you go here, UI dashboard. So dashboard is the web-based Kubernetes user interface. So dashboard is the web-based. That is nothing but GUI, and you can use dashboard to deploy containerized application to the Kubernetes cluster. Troubleshoot your containerized application, manage the cluster itself along with its available resource as well. And so there is a kubelet. Kubelet is a command and interface tool. This is nothing but a command. We can use kubelet. This is a command line interface, like right, like this. We'll see one by. This is command line interface. Everything we are executing via command prompt only. Everything we are executing via command prompt only. Via command prompt only. So we can execute query two ways. Whether we can execute your query via GUI, or else we can execute your query so via right, through CLI also, command line interface also. So the request first go to who received that request, API server. Request ఎవరికి వెళ్తుంది ఫస్ట్? ఏపీఐ సర్వర్కి వెళ్తుంది. ఏపీఐ సర్వర్ రీడ్ యువర్ రిక్వెస్ట్. సేమ్ లైక్ డాకర్. ఇఫ్ యూ సెండ్ డాకర్ క్లయింట్, డాకర్ డీమాన్, రైట్? If you send any request, the request go to Docker daemon. Docker daemon knows which you are expecting, and based on this, so I execute the query. We are getting the you are getting the output response and all. Same way, if you send any query here, kubelet or via GUI or CLI, the request go to master. That is nothing but API server. API server read your request, and this information it is stored into the etcd. It is the key and value format. Which format it is storing? etcd key and format. Right? Key and what is key? For example, name equal to, for example, Karthik. This is the key and value format. This is the key and value format. This is the key and value format. So this information and all it is stored into the key and value format. This is nothing but a key and value. This is a key and this is a value. This is like small db. Whatever you are sending, that entire information it is stored into the etcd. And with the help of scheduler, with the help of controller, and so we can deploy. Now see here same. Now what is kubectl? Command line. This is the kubectl is the command line configuration tool. Command line configuration tool. Command line configuration tool for Kubernetes used to interact with the master node for Kubernetes. kubectl has the config file called kubeconfig. So that kubectl it is has one file. What is that file name? Kubeconfig. Just try to understand. These are the new terminology. Slowly we can understand. Now what is worker node? What is master worker node? And what is the kubectl? And these are the new terms, right? So try to understand. Slowly we can understand. Okay. Kubectl is the command line configuration tool. Command line configuration tool. And see here. And use it to interact with the master node of the Kubernetes. So what is the purpose? See, for Kubernetes use it to interact with the master node Kubernetes. kubectl has config file called kubeconfig. kubectl has a config file. So kubectl has a one file. What is that file name? Kubeconfig. Kubeconfig. This file has the information about server and authentication information to access the API server. Okay. What is this? kubectl has one file. That file name is kubeconfig. So that file name is kubeconfig. So that file name is kubeconfig. That file name is kubeconfig. One second. Hello. క్లాస్ జాయిన్ పతా ఉంది. కనెక్ట్ యాక్సెప్ట్ కొట్టు. Okay, so now, so this is the, so this is the what is this used to interact. What is the main purpose of kubectl? Kubectl main purpose is interact with the master node. What is the main purpose? Interact with the master node. And kubectl has one file. What is that file name? Kubeconfig. What is that file name? Kubeconfig. So kubectl has one file. So once you set up Kubernetes, we can see this file. Kubectl has one file, kubeconfig file. This file has the information about server and authentication information to access the API server. So what this file has? This file has some information. The file has the information about server, and so it is has some server information as well as authentication information to access the API server. You know what is API server? This is act like a front controller, like a front desk. Okay. If we send any request, the request go to API server only. First API server receives your request and kubectl has one file, kubeconfig file. In this kubeconfig file, it has server information and authentication information to access the API server. Now got it, Karthik? Clear? Any doubt as of now?
Yes, sir.
Okay. Now,
No,
if you go to here, master. Now see here, master has a API server. What is AC? Cube API server interact with API. It is a front end of the Kubernetes control plane, communication center for developers, system admin, and other Kubernetes components. So this is like a front desk. What is API server? API server act like a front desk. If we send any request, the request first go to who will receive? API server only receive. So API server based on API server knows. Now see it is acting as a front end of the Kubernetes control plane. Communication center for developers, system administrators, or anything. This is the API server. Now, if you go to here, what is scheduler? Now, etcd. Etcd is the simple distributed key value store. What is etcd? This is the distributed key value pair store. Kubernetes uses etcd, its database. So Kubernetes uses etcd, its database. Like it is acting as a database. This is acting like a DB database. Database. In this database, it is maintaining key and value format. See here, it is stored. Use database to store all cluster data information. Some of the data stored in each job scheduling information, parts information, state information, everything it is maintaining under the etcd only. It is like a simple database. It is Kubernetes uses etcd as its database. It stores it is stores data into key and value format. That entire information. What is we are doing? That information and all it is maintaining in the etcd. Now, if you go to here, control, scheduler and controller. What is scheduler? See here, scheduler. Scheduler watches the parts and assign parts to run on specific host. Schedule means here you know right. This is the worker node. This is the worker node 2. This is the worker node 3. This is the master. And if we create here new terminologies parts, right? Here new terminologies parts. We'll discuss later. What is part? Part is nothing but this is the smallest instance to run your application. This is the small instance to run your application. Okay. So we are creating containers, right? All containers running inside pod only. Inside pod only. Okay. So leave it. We'll discuss later. Now, if you go here, now scheduler. Scheduler watches the parts. What of scheduler role? It is watches the parts. How many parts? Which part where we want to run? This is a pod. This is a pod, right? So which worker node? Which worker node? This is a parts. This parts is running where you want to execute. So whether you need to execute worker node 1 or worker node 2 or worker node 3. So that and all taking care by scheduler. See, scheduler watches the parts and assign parts to run on specific host. Which host mission you want to execute? Which worker node? Whether you want to execute worker node 2 or worker node 3 or worker node 1. So that and all taking care by scheduler. Scheduler means that is right assign which worker node you want to execute. So that is nothing but scheduler watches the parts. Scheduler watches the parts and assign the parts to run on specific host and assign to run on specific host. So this is the scheduler. Now if you go to controller, this is the one more main controller. Last one, this is the controller. What control will do? Now observe here. Controller. Controller manager runs the controllers in background which runs a different task in Kubernetes cluster. Perform the cluster level functions like replicas, keeping track of worker nodes and handling nodes failures. So that and all it is taken care by controller. Now, if you go to here controller, there is many controllers available inside controller. Node controller. Node means this is my worker node. This is the worker node 1, this is the worker node 2, this is the worker node 3. Now see here there is one control node controller. It is responsible for noticing and responsible responding when nodes is go down. Suppose if any machine is not working, if any this worker node is not working, or this is goes down, that information handling who is node controller and replicas controller replication controller it is maintain the number of parts replication controller means maintain the number of parts how many parts you want to create, how many parts are running, how many parts are inactive, how many parts are deleted. It is maintaining that information. See here replication controller. It maintains the number of parts. It controls how many identical copies of the parts should be running somewhere on the cluster. How many parts you want to execute. So that and all it is taken care by replication controller. Node controller taking care by nodes. Whether nodes are running properly or not, any worker node is down or not. And there is a endpoint controller, join the servers and parts together. There are many controllers available here. Slowly we can understand. Endpoint controllers, joins, services and parts together. So it is coming. Endpoint is nothing but this is communication controls controller and it is checking services and parts together. And replica sector controls number of replicas, how many parts you want to running at the all time. See here number of replication of parts running at a time. Now this features is not available in Docker. For example, how many containers you want to execute? Do you have any count in Docker? No, right? Yesterday already we seen. If I delete one part, if we delete one container, it won't recreate automatically. We have to create manually. And so how many containers I want to running? Keep on. Always how many containers I want to run. So that features also not available in Docker. But here if you come to here, there is a replication controller and replication controller replication set there is many objects available and see here so with the help of we can easily handle how many parts you want to run. Now there is a deployment controller, declarative update for pods and replica set. There is a daemon controller, ensures all nodes run copy of specific pods. And job controller, supervisor. Job controller is nothing but this is a supervisor. It controls and carrying out batch jobs. Batch. How it will executing batch and all that and all taken care by this. There is many controllers. There is node controller, replication controller, endpoint controller, replica set controller, deployment controller, daemon set controller, and jobs controller. There is many controllers available in right controller manager. And so each point it is taken care by one particular task. See here, node controller taking only nodes, replication controller taking only parts. Endpoint it is taking only service and service giant that is connection and as daemon set it will take only update part that is the update of the your that is update for the parts and replica set. If you want to scale up we can scale up, if you want to scale down we can scale down. That and all taking daemon set. Daemon set is nothing but this is also one controller and every pod every worker node it is maintaining one specific node. See, ensure all nodes run one copy of specific pod. For every worker node, if you want to execute one specific task, that case we go for this is the demand setter. Now jobs controller. This is the supervisor. This is the supervisor. So these are the main components in master. See here, API server, scheduler, controller, etc. Now, if we send any request, first the request go to API server. API server read your request. That information and API server read your our request, and so that entire information it is stored into the etcd. It with the key and value form. This is like a simple database. It store entire information in key and value format. And there is a scheduler. There is a scheduler and there is a controller. These are the main components. Now same way, if we come to worker node, every worker node has these are the common main components. See pods, docker, kubelet and kubeproxy. Docker, kubelet, kubelet, kubeproxy, docker and pods. So every worker node. Now if you go here, now if you go here now if you go here, Kubernetes components. If you go here, worker nodes. Now see here, worker nodes are the nodes where the application actually running. Suppose you deployed one application. So where it is running? It is running master or worker node. Correct? If you deployed any application. So your application running master or worker node. Where is your parts? Master or worker node?
Work notes, sir.
Worker node. So your application is running here only, not master. So just blindly remember our applications are running only worker node. Applications are running only worker node, not in master. Okay. So this is a basic point. Just make sure that worker nodes are nodes where applications actually running in the Kubernetes clusters. It is known as minion. This is the same like see here kubelet container and all. Anyway, if we set up, we can easily understand how it will work. So these each worker node are controlled by master node using kubelet processor. Who is handling these all worker nodes? Now I have three worker nodes. Who are handling these three worker nodes? Only who are working, who are handling. ఎవరు హ్యాండిల్ చేస్తారు వర్కర్ నోట్స్ ని? Only master. Master is like it is like manager. Just assume. Okay. So this is the all worker nodes managed by master. Clear, Karthik? All worker nodes managed by master. Applications actually running worker nodes only, not in master. Our applications are running only worker nodes, not in master. I hope you got it right, Karthik. Clear?
Clear, sir.
ఓకే. సో వర్కర్ నోట్స్ మొత్తాన్ని హ్యాండిల్ చేసేది ఎవరు? మాస్టర్. ఇవన్నీ వర్క్ అవుతా ఉందా, ప్రాపర్గా రన్ అవుతా ఉందా, ఎవ్రీథింగ్. మాస్టర్లో మళ్ళీ మనకి మల్టిపుల్ కాంపోనెంట్స్ ఉంటాయి. ఏపీఐ సర్వర్ ఉంది, ఈటీసీడీ, స్కెడ్యూలర్, కంట్రోలర్. సో సో దీస్ ఆల్ ఆర్ విత్ ద హెల్ప్ ఆఫ్ దీస్ కాంపోనెంట్స్ వీఆర్ హ్యాండ్లింగ్ అవర్ వర్కర్ నోట్స్, వీఆర్ రన్నింగ్ అవర్ వర్కర్ నోట్స్. But our actual, so our applications are running only worker node. But these worker nodes and all managed by master only, managed by Kubernetes master. Got it? Now come to here. Now see here. So each worker nodes are controlled by master. This is the basic point. So all worker nodes controlled by master only. Now container platform must be running on each worker node and its work together with the kubelet to run the containers. So if you want to execute any command, how we are executing? There is two ways we can run. One is kubectl and other one is GUI. UI, that is the graphical user interface or UI. And see, we can also use other container platform like Core OS, Rocket. So we can use other way also. So mostly here we are using with the help of kubectl only. With the help of kubectl only. Now see here what is kubelet. What is kubelet? Now if you go to here, this is the kubelet, right? So where is that? This is the kubelet. This is the kubelet. And here this is the kubectl command prompt. We are executing commands. And there is a one component, worker node, kubelet. So what is the main purpose? See here, kubelet is the primary node agent run on each nodes and reads the container manifest, which ensures that containers are running or healthy or not. Now see here, this is the primary node agent. This is the primary node agent. Now we know, right? Agent is nothing but mediator. Correct. Agent is nothing but mediator. Suppose if you want to buy any LIC, one policy. So there is many agents available, right? LIC agents. What they will do? So if you ask, I need one LIC policy means everything taken care by that mediator only. You don't worry. They are giving, they are explaining many, rate plans, and so what is the amount? Everything taken care by agents. Same way, this is the kubelet. Kubelet is the primary node agent, runs on each nodes. See here, primary. Kubelet is the primary node agent, runs on each node. So every node it is running kubelet. Every worker node it is running one kubelet. This is like agent. This is like agent. This is like agent in each worker node. Now see, each worker runs on the each nodes and reads the container manifest. So here we have multiple containers, right? This is the pod. Inside pod running multiple containers. This is the pod. Inside pods it is running multiple containers. So inside the pod it is running multiple containers. See here, container manifest, which ensures that containers are running healthy or not. And it is checking whether these containers are running healthy or do we have any problems. So that and all it is taken care by kubelet. Kubelet is the agent. Kubelet is the primary node agent, runs on each worker node and it reads the container manifest file and it is checking whether containers are running or healthy or not. That's it, very simple. And it makes sure that containers are running in the pod. The kubelet does not manage the containers which were not created by Kubernetes. And the kubelet it won't take any care. And so this is also some parts. API server, etcd. So kubelet it won't take anything. So which is managed, which is created by, which were not created by Kubernetes, which were not created by Kubernetes. So simply if you want to understand what is kubelet, kubelet is nothing but primary node agent run on each worker node. And what it will do, it read the container manifest file and it is checking whether all containers are running or not, or containers are healthy or not. Got it? Got it, Karthik? Any doubt here? What is kubelet?
No doubt.
So if you understand these points, nothing, very simple. We can easily remaining and all only execution the commands only. Now what is kube proxy? You know, right? So in Docker we created multiple containers. How these containers are communicate each other with the help of Docker? ఇవన్నీ ఎలా కమ్యూనికేట్ అవుతాయి డాకర్లో? There is one concept, right? What is that concept? Karthik. This is the container 1 and this is the container 2. How these container communicate each other? You know, right? Docker network. Yes or no?
Yes, sir.
So there is a network, a bridge network. By default, if we create any container, which is the default network? Bridge network. Correct? So with the help of bridge network, these containers communicate each other. Clear? This is the Docker. In Docker, even if you are not created, even if you not assign any network, by default Docker itself it is assigning one network. What is that network name? Bridge network. What is that network name? Bridge network. Okay. Now same way, if we come to Kubernetes, see here there is a kube proxy. See, kube proxy enable the Kubernetes service abstraction by maintaining network rules on the host and performing connection forwarding. So what is this? This is the network rules. It is maintaining a kube proxy maintaining network rules on the host, network rules on the host and performing connections. How these parts connecting each other, how these worker nodes connecting each other. So that and all everything taken care by kube proxy only. Queue proxy maintaining network rules on the nodes. Network rules. Network rules on the nodes. These network rules allow network communication to your pods from inside or outside of your cluster. So this is my pod. This is my pod. My pod is running here. How can I access my application? How to access my application outside? Like I mean to say browser or anywhere. So that and all taken care by kube proxy. See here, kube proxy is nothing but kube proxy maintaining network rules on the nodes. Network rules on the node. These network rules allow network communication to your parts. How these parts are communicate each other and how these are connecting each other. That and all taking care by kube proxy only. Now it helps us to have network proxy and load balancer for service in the single worker node. And service is just like logical concept and the real work is being done by the kube proxy only. So here there is one more object is there service and the service is like this is also an object. Service is just like logical concept. The real work is being done by the kube proxy pod and that is running on the each worker node. It redirect request from cluster that is the virtual IP address to the pod IP. Clear, Karthik? Any doubt here? These are the
No, sir.
mostly it is the rules, network rules, and these rules allow network communication to your pods inside or outside of your cluster. Inside or outside of the cluster. Very simple. In interview also, so one or two people they asked what is queue proxy? Queue proxy maintaining network rules on the worker nodes. These network rules allow network communication to your pods from inside or outside of your cluster. So the network rules allow network communication to your pods from inside or outside of your cluster. Okay, that's enough. And what is the kubelet? You know what is this and Docker and all? You know what is Docker and all already? You know, right? Docker and all. You know what is pod? Now we'll see what is pod. Pod is nothing but this is the smallest runtime instance. Pod is nothing but this is the small. It is pod life cycle here pod. What is pod? Now this is very main role. So all containers running inside the pod only. Now first we will discuss what is pod. Pod always run on node. Just blindly remember pods mostly running where node only worker nodes. Pods always running worker nodes only. So whether it is running here or whether it is running here or here, wherever it may be, based on scheduler, it is running. A pod is the smallest building block or basic unit of scheduling the Kubernetes. Pod is the smallest building block or basic unit. So, mostly interview also they are asking what is pod Kubernetes. What is pod? See here, pod is the smallest execution unit in Kubernetes. Pod encapsulates one or more applications. Pods are emperor by nature. If pod is fails, Kubernetes can automatically create a new replica of the pod and all. So this is the official website. If you want to know more about, so pod is the group of one or more containers with shared storage and network resources and specific and all. So there is multiple ways we can give definition whatever you want. See here, this is the official website kubernetes.io and the same way pod is the smallest deployment unit of computing that you can create and manage your Kubernetes. So pod is the smallest deployable unit of computing that you can create or manage your cluster. Pod is a group of one or more containers. Maybe single pod container, multi-container. Now see here in Kubernetes cluster, pod represents running process. What is a pod? Pod is representing a pod represents a running process. Inside pod, we can have one or more containers. So inside pod, we can create one or more containers. So here each pod has one container. So this is a pod, right? Every pod has one container. And if you want to, we can create multiple containers inside the pod also. See, inside pod, you can have one or more containers. So those containers all share the unique network IP, storage, network, and any other specification applied to the pod. Applied to the pod. Pod is the group of one or more containers. So maybe single pod container or multi container pod also. See, so pod is a group one or more containers. So mostly, if you want to, we can create one container, or if you want to, we can create multiple containers in one pod also, which is running on the same node, which is running on the some node. Now pod is an abstraction network stored away from the underlying containers, and so each pod has unique IP address. So this is a pod, right? So this pod has unique IP address. Each pod has unique IP address, and so within the cluster, and any data saved inside the pod will disappearing without persisting storage. Now here we are using persistent storage, and in Docker we are using a volume concept, right? Here this is the PV and PVC. Only terminal is same, remaining same concept only. Now if you observe here, so this is my pod. So maybe pod has one container or multiple containers. See here, this is a pod. How many containers here? Three containers. This is a pod. How many containers? Only one. This is also pod. How many containers are running? Two containers. So that is your wish. So this is the single container. This is the single container pod. This is the multi-container pod. Multiple containers running here. So here only one pod, one container is running. Here two containers are running. So that is based on requirement. We can create single pod, single container pod or multi-container pod. Got it, Karthik? So this is the pod always run in the worker node, and each pod has unique IP address, and so each pod has some storage, each pod has some network, and any other resource specifications applied to the pod. All these resources used by containers. So every pod has one unique IP address, and every pod has some storage, and every pod has some network. And so if we create any container inside the pod, so this existing these resources used by containers only. These resources used by containers only. Clear, Karthik?
Clear.
So this is the main role. Mostly next 1 week or 10 days we are discussing pod only. Must try to understand what is pod. Pod always run on the worker node, and this pod is nothing but this is the smallest building block or basic unit of scheduling the Kubernetes. Or this is the smallest instance to run your application. So we can say anyway. But enter most of the people they are asking what is pod. Okay, just noted one line answer. Whatever you know, just keep it. Okay, and so every pod, see all the each pod has unique IP address. So each pod has unique IP address, and so it has one or more containers. So inside the pod, we can have one or more containers. If you want to, we can create single container, or if you want to, we can create multiple containers also. And so those containers all share the unique IP address, and so in net that is some storage. Every pod has some storage, and also network, and any other specification whatever that pod has. Everything used by containers only. Now there is a pod life cycle also is there. So we'll see later what is pod life cycle. Make a pod request API server using the local pod definition file. API server saves the information in etcd, and scheduler finds the scheduler. Whatever we discussed, right? Same story I explained. See here, this is the pod life cycle. So how pod is creating, how pod is destroying, so that and all. See, if you pod request to API server and local pod definition file, API server saves that information in etcd, and scheduler finds the unscheduled pods and schedule into a specific worker node, and a kubelet running on the node. See the pod scheduler, and face is face of Docker, and so Docker run on the container. The entire life cycle start of the pod is stored into the etcd only. Etcd only. So how it is pod is creating, how that pod is handled by. So this is the pod life cycle. We'll see later how it will unsolve. This is the pod is temporal, that is lasting for a very short time. There's types of pods also is there. Single pod, one container per pod, or we can see multi-container pod. That is nothing but a sidecar. Sidecar nothing. Sidecar or multi-container pod both are same only. Don't confuse. This is the one container per pod. This is a single container pod. This is a multi-container pod. Multi-container pod. So that is nothing but in one pod. If you want to, we can create a one. In one pod, if we want to, we can create one container, or if you want to, we can create multiple containers also. Same like this is the single container pod. This is the multi-container pod. This simply we are calling sidecar. Simply we are calling sidecar. Simply we are calling sidecar. This is the single container pod. Anyway, coming classes we'll discuss all these things. Now I hope you got some idea, right? What Karthik? So any doubt as of now? We'll see later this and that.
No doubt.
Okay. So next class we'll see how to set up local mission, how to set up local mission, all these right this Kubernetes setup and all, and how to execute some Kubernetes resources and all. We'll see coming class next class. Okay.